So our next learning target is prime numbers. So the first thing we're going to do is remind ourselves of what a prime and a composite number are. So turn to the vocab section either in your notebooks or find that note that you created in Notability for vocab and continue adding to that. You don't have to start a new sheet of paper. So remember, a prime number is any number that has exactly two factors, 1 and itself. 1 is not a prime number because it only has one factor, itself. Some examples of prime numbers: 2, because 1 times 2 is 2. There's no other way to multiply to 2. 5 for the same reason. And 19. There's no other way to multiply to 19 except 1 times 19. A composite number has more than two factors. So again, 1 is not composite. It's kind of a special number because it has only one factor. A composite number has to have more than two factors. An example of a composite number is 12. There's 3 different ways to multiply to 12. 1 times 12, 2 times 6, and 3 times 4. So if there's more than one way to multiply to the number, then it's composite. First thing that I want you to do is label your notes. So either start a new note in Notability or turn to your next clean sheet of paper after your learning target number 1 notes. Label the top. Our objective: I can differentiate between prime and composite numbers. And then I want you to pause the video. The reason I want you to pause the video is because I want you to try this example on your own. Can you determine these 4 numbers, are they prime or composite? Once you have done that, go ahead and hit play and I will go over the answer. So for the first one, we just looked at 2. We said it was prime. There's only one way to multiply to 2. 1 times 2. It has 2 factors, 1 in itself. 27, I hope you recognize we can rewrite this as 3 times 9, therefore it's composite. For 47, that might be a little more challenging. I can't think right off the top of my head if it's on my multiplication chart. There are several divisibility rules that are helpful in a case like this to determine whether or not a number is prime. If the number is even, it's automatically composite, other than 2, because 2 goes into every even number. If you add the digits together, and what I mean by that is the first digit is 4 and the second digit is 7. If the sum of the digits is divisible by 3, then the whole number is divisible by 3. So 47 is not divisible by 3. It's not even, so 4, 6, 8, 10, none of those will go into it. It doesn't end in a 5 or a 0, so it's not divisible by 5. 7 times 7 is 49, so it's not divisible by 7. This number is prime. 63, hopefully you recognize this right away as 9 times 7. If not, 6 plus 3 is 9, which is divisible by 3. So this is composite. Next, we're going to take a look at how to tell whether or not variables are prime or composite. So what I would like you to do is, again, pause the video, take a guess as to whether or not you think these expressions are prime or composite, and then go ahead and hit play and I'll explain. So the first one, we have 2 times x. Well, 2 is prime, but this expression can be rewritten as 2 times x, which is not the same thing as 1 times the number, because we can split that up. So anytime you are multiplying, it is composite, even if the 2 pieces are prime. So for example, think about 5 is prime and 7 is prime, but if I multiply them together, my result will never be prime. So it's got to be a single number or a single variable. So looking at B, we've got a single variable. The only way I can write this is 1 times y, so this is prime. On C, I have a single variable, but it has an exponent, which means I can rewrite it as m times m. Now, if you're not sure why this is composite instead of prime, think about 25. It can be rewritten as 5 times 5, therefore it's composite. And of course, this can be rewritten as a times b times c, so it is composite. And your turn. Make sure that you try these tonight. Tell me whether or not they are prime or composite, and then come to class ready to justify your answer with your classmates.